Hello, everyone. My name is David Cheng. This is McWherter, and I'd like to welcome you all to Infra 203. Today, we're going to talk about best practices for enterprise deployments on Google Compute Engine. So before we get started, I want to let you all know that your feedback is greatly appreciated. So at the end of the session, if you wouldn't mind logging in and letting us know what you think, we'd really appreciate that. So to get started, we wanted to open with this. Our goal, our North Star here at Google, is that we would be the easiest cloud for enterprise. And to unpack that a bit, it's not just about providing a cloud that's simple and elegant, but more around this idea that if we can make a cloud that works for you through ease of use, automation, and surfacing intelligence, that you would spend less time grappling with getting cloud into the right places and be able to spend more time delivering value to your end users. And so today we're going to cover 3 topics in this session. We'll go over things we're doing to simplify deployment and management of VMs. We'll cover the ways we're automating security and governance for your workloads. And then finally, we'll cover the intelligence we're surfacing to help you save even more money on Google Compute Engine. So to start, deployment and the management of your instances starts with this notion of choosing the right VMs. VMs are the fundamental building block for which Compute Engine operates. So the way we think about VMs is this. There are 3 instance families here. There's general purpose, compute optimized, and memory optimized. The high-level summary of this is general optimized is going to be your balanced workloads, best TCO, best performance per price. Compute optimized, this is if you have higher horsepower needs and think gaming, think HPC. And then lastly, for your high-end DBs, we have memory optimized up to 9 terabytes. And so a few things to call out as I'm going through this. The first one is that under our general purpose, we are launching a new AMD SKU. So if you have workloads that aren't dependent on Intel and vendor agnostic, this is could be a low-cost option for you to consider. The second item is that there's a session tomorrow afternoon, Infra 102, that'll detail. So if you have workloads that kind of sit right in between, maybe you're somewhere between general purpose or compute optimized, and you want more of the technical details about clock speed of CPU platform, things like that, you can attend that session, and that'll really break down the nitty-gritty details. And the third item here is, it's not called out, but there are 2 other flavors. If you can imagine these as vertical pillars, 3 of them, there's a couple horizontal flavors of these that you can talk about, you can spin up as well, preemptable VMs, as well as sole tenant nodes. And so we'll cover that actually right now. Preemptable VMs, this is for workloads if you have batch checkpointed or maybe some high throughput computing, but want a low-cost option. This is generally where we try to direct enterprise customers. The summary for preemptable VMs looks like this. They have a maximum lifetime of 24 hours. They can get preempted. They can get terminated with only a 30-second notice. But the way that we recommend enterprises handle this is you use cleanup and startup and shutdown scripts that we've templatized so that you don't have to try to reinvent the wheel. So we have a lot of templates out there that you can use. And the power of preemptables, especially if you think about genomics, maybe image rendering, Monte Carlo simulations for finance, is that you're effectively expressing this trade-off of, hey, I'm willing to sacrifice the duration of my instance for the ability to have a fixed, predictable, low-price instance. And so let's get into the implementation of this. The way that you would create a preemptable VM is all you have to do is call the exact same G-Cloud compute instances create, specify the machine type, the zone, and at the end of it, you just slap on the -- preemptable flag. To drill into actually a real-world example of preemptables and how it's used, Andrew V. Sutherland, he was a researcher, I think this is about a year ago, and I'll actually have to read this. He explored 10 to the 17th hyperelliptic curves of genus 3 in an effort to find out curves whose L functions have potential interesting Sato-Tate distributions. So he was working on that. I think he likened it to about finding a needle in a 15-dimensional haystack, which maybe will help you grapple your minds around that a little bit more. But he was working on a very complex math problem, and this chart right here actually shows his activity, his usage rate over that day. And so you can see in the morning around 7 a.m., he started to spin up his workloads. And he was actually able to get almost 600,000 cores in a few hours, preemptable cores in a few hours. I think he broke for lunch, spent about an hour, and then spun up again around 12:30. And you see a little post-lunch lethargy plateau before he went up again to almost 600,000 cores again. And so that's something that kind of really highlights a few things here. One is the ability to spin up and auto-scale and add preemptable cores on demand and spin up these huge workloads to solve very difficult computational problems. And then second is this notion that he did it at a fraction of the cost, at 20% of the cost for him. I think he got about 300 core years worth for about 20,000 US dollars. In case you were interested in the end of the story, the narrative goes, he was able to find about 70,000 curves that eventually made its way into a scientific database. So this is just a real-world example here of the power of preemptables. Again, if you're able to take advantage of it using the startup and shutdown scripts, and you have these image rendering workloads and are able to do high processing with the ability to trade off duration, that's something that we always recommend for enterprise customers. The second cross-cutting flavor of these instances is going to be your sole tenant nodes. This is dedicated hardware offering. So if you have compliance, security, so think finance or healthcare, if you have those types of requirements, other customers come to us with hardware isolation needs. So if you have some very performance sensitive that you don't want to deal with noisy neighbors for some period of time, you can come on to sole tenant nodes. And the way that sole tenant nodes work is it's, again, dedicated hardware. And we think about it like this. It's the same regular VMs that you would schedule as any other instance, except for, and it's on any regular machine that we have. We either clear out a physical host or we find an empty host, and then we make sure it's reserved for you and your project. So you have full access and control to what's running on that host. And so there is a 10% premium for that exclusivity, and you are able to use 1 or 3 year CUDs, and as well as purchase them on demand. And the reason I wanted to spend a little bit of time on sole tenant nodes is we see a lot of enterprises dabbling and adopting this, and there are a few best practices that we've seen work well for some enterprises. And at the core, the way that you create a sole tenant node is you express a node template. That's effectively the size and type of host that you are looking for. And then you can spin up node groups. Each group represents, so here I've spun up 2 node groups of 3. So each of these, this is 6 total physical servers that I've reserved. One set in Europe West 2A and one set in Europe West 2B. And then now that you have these reserved, again, there's 6 empty physical hosts with capacity that's ready for you to use, and you pay for that flat capacity. And so you can start to schedule instances onto those hosts, and you can schedule it through 3 mechanisms. The first is through this -- node. This allows you to schedule an instance onto a specific physical host. And we see customers using this for the ability to say, I want these 2 instances co-located together, or maybe I want them absolutely on separate machines so that I don't have the same failure domain. Another mechanism we see is this use of node group, and this allows you to say, not just one node, but any host in this set of nodes in this zone. And again, this would allow you to separate one group from another. And then the last one is on an affinity label, so I can specify something like, this is my production group or groups, and then these are my development groups, and you can land instances onto that. A few interesting things that we built out to help ease the use of sole tenant nodes are, one, we have auto scaling, and this is this idea of customers don't want to be mindful of how many hosts that they have, and so you have transparent auto scaling of your node group. So you set a min and max size, will automatically add and remove hosts depending on your usage. And then the other exciting feature that we are launching is CPU overcommit. This allows you, again, remember you're paying for the flat host price, and what CPU overcommit allows you to do, similar, you might use tools like on-prem that allow you to do this, but this allows you to oversubscribe your host up to 4x, and this is for vCPU. This is in alpha and going to beta. And so the next section we want to talk about, now that you kind of understand how we think about our workloads, the next section is a few things that we'll call out around how to manage data. And actually, I wanted to focus specifically on snapshots because we're seeing a lot of adoption from enterprise customers. And so a few things here. The first one is that for regulatory or compliance reasons, a lot of customers are expressing, hey, I need to make sure that my snapshot data is located in a certain region or a certain zone. And so you can do this through snapshot locations. Effectively, you just specify the location of the snapshot that you're trying to create, and it'll ensure that's in a US or Europe or South America zone. The second thing is now that you're able to specify the zone, we also have a feature that went GA recently called Schedule Snapshots. And snapshots take the delta of their aggregate deltas from the previous disk, and so they're low cost. And what we see customers doing here is creating backups of their disks. And so for scheduled snapshots, you would create a resource policy, and this allows you to specify the time, maybe the max retention date, and other metadata for how you want the cadence of the snapshot to happen. And then you have this resource that's floating, which you can apply to any number of instances as you're going. So here I've taken that previous snapshot, I called it schedule name, and I can attach it to the disk of an instance. And so next, Cash is going to talk about what we're doing to automate and the tools around how we're helping you secure and govern your cloud.
Thanks. I'm here to talk to you about three things. The first is figuring out how to integrate Google Cloud with your existing on-prem systems, of which I'm sure you have many that you've invested heavily in over the past years in your enterprises. The second, I'm going to talk about once you start bringing your workloads into Google Cloud, how do you secure them? And then finally, compliance issues. Let's start with integrating with your on-prem systems. Most of you have existing on-prem systems running various workloads and applications, services, et cetera, on your on-prem clusters or your production clusters, and you're interested in moving some of it to Google Cloud. That's going to involve figuring a way of bridging both your networking resources and your identity and directory resources with Google Cloud. Let's start with networking. We provide a couple of options. This is the first one, which is what we call Cloud Vpn, and it's just the same as if you have your VPN configured for your mobile employees or your remote sites. You can connect your on-premises network over IPsec tunnels directly to the Google data center, where they terminate directly into the compute virtual network, putting your virtual machines on your virtual network and giving them access to everything that you have at home. This is a high availability system. You can configure it in a number of different ways to provide even more availability with failovers and various things like this. The second thing is if you have very particular and distinguished networking requirements, you can use what we call Google Cloud Interconnect, which allows you to bring your network to a Google point of presence and essentially connect your network directly to our networking hardware and drop your network directly onto your virtual, and tunnel your network directly onto the Google virtual network, putting your virtual machines even closer and with more bandwidth to your on-prem systems. We have a couple options here as well, 10 gig, 100 gig connectivity. The sky's really the limit. Now that we've talked about networking, let's look at identity and directory services. Most of you probably have invested heavily in getting your employees in your existing systems into your federated or into your directory services. You've set up groups and ACLs and in regard to your business modeling. You'd like to bring that into Google Cloud. The first thing you're going to want to do is bind or sync your Active Directory to Google with the Google Cloud Directory Sync. This is going to allow you to not have to create separate accounts that you have to manage and keep track of who's logging in where with what account and so forth and so on. They log in with the account that you provided using your directory services, and they single sign on to Google, and they can access anything in Google Cloud. And you can actually then go and grant access to your Active Directory groups, and your employees can get started using the cloud in this mechanism as soon as they're hired. The second thing I'd like to talk about is moving your services and hoisting the services that depend on your Active Directory systems into Google Cloud. Naturally, you don't want to have to phone home every time you need to federate with your Active Directory or other LDAP services. We provide a managed service for Microsoft Active Directory. If you enable this, you can get we'll create and manage an Active Directory instance running inside of your, co-located to your cloud, and all you have to do is join it with your domain controller, and you're off to the races. Anything that was running on your on-prem systems can now run in Google Cloud with high availability and low latency. Now that we've covered the basics of integrating with Google Cloud, I'd like to talk about securing this infrastructure that you've deployed to the cloud. I think every enterprise's worst case scenario and worst fear is looking at the cloud and seeing a vast, uncontrolled urban sprawl of developers deploying random things with random policies and random standards to their cloud, and then somehow, after the fact, going back and make sense of it. Every developer is inclined to do something that makes sense to them, and not necessarily something that makes sense in aggregate. We found that if you get out in front of it and you provide strong controls and guidelines, you can actually prevent the wide urban sprawl and have some semblance of control over your cloud resources. And so in Google Cloud, how you do this is you use what we call the cloud resource hierarchy. It essentially consists of a set of folders and projects in which all of your resources reside. You can construct an arrangement of folders and an arrangement of projects that suits your needs. And in particular, we think that it's important to construct this resource hierarchy in such a way that each node in the hierarchy is a place where you're delegating responsibility to some responsible group of entities or teams in your organization. And here you can see a common scenario where you've essentially broken your organization into a production zone and a corporate zone where you can run your HR systems in your corporate zone with a certain set of policies for managing your own corporate data with whatever policies you require there, and you can run your production systems in an alternate zone with a different set of policies. And likewise, when you start building applications, you can start building those in folders, and developers can organize and create projects underneath in regard, consistent with their development and production and staging environments, and have policies that are different yet consistent across these environments. And in general, in Google Cloud, policies will apply hierarchically and apply to everything below them in the hierarchy. So if I set a policy on the folder for the production environment, it will trickle down and affect everything in the production environment. Now let's look at the kinds of policies that you're going to be interested in as a customer of Google Cloud. The first is IAM policies, and the second is organization policies. IAM policies is how you grant access to the resources within the cloud. Organization policies is after you've granted access, how do you control what can actually be done in the cloud? And let's give some examples. So this is the basic idea for an IAM policy. It's a statement of who has access to do what to your resources. Again, here's an example set policy command where we're setting the policy of a folder. We're granting a single user, cache@google.com, the ability to administrate compute instances at that folder and below that folder in the hierarchy. So some more examples. Here we can start from the basics. Let's grant access to the organization node to all of our all of our security engineers and our compliance tooling, so that they can go and scan my hierarchy and look for all the resources and figure out if they're compliant or not with my particular security requirements. We have a role here called compute.securityadmin, which gives a set of permissions which allow you to scan particular resources within your compute hierarchy. Next, I can go and find myself a team that I can use to manage my production operating system images in my production environments. Those operating systems will include all sorts of infrastructure and monitoring and telemetry, and I want to make sure that they're security reviewed and so forth and so on. I can develop that team, and I can delegate responsibility to them to manage a set of resources within my tree, and I can grant them storage admin, which lets them create images and manage images. Likewise, when creating an application, I can delegate access to use the images in my production images folder, and I can also grant them compute access to develop applications within their folders. Oh golly, I made a mistake. I'm sorry. I granted too much power to those developers. Those rascals, they probably will do things that I will regret later. One of the things we have in Google Cloud is a principle of least privilege. We strongly We strongly encourage it. We strongly recommend it. And it's basically the idea that if you're granting access in your cloud, you're going to grant as little access as necessary to achieve the business objectives of the people or services you're granting access to. Now, developers don't always have security as the top of mind. Their priority is shipping their application, developing their application, and learning how the system works. And they're going to sometimes do things that are not necessarily the most secure thing if they have the ability to do so. They might even have their best interest in mind, right? They might intend to come back later and fix the ACLs and fix the keys and this, that, and the other, but sometimes they fail to do so. And then you're left with an insecure cloud. How do we do this? How do we deal with these kinds of problems? So the first thing we'd like to talk about is IAM Role Recommender, which we've recently launched, which analyzes every user's and service's accesses to your cloud and your cloud resources. We look at all the accesses, and we run them through a machine learning system, which then tries to categorize their accesses based on other types of accesses that we've seen, and we provide recommendations to you to reduce the privileges of overbroad access grants and apply more specific targeted roles. A lot of customers have had success just taking the recommendations that we give them and applying them out of the box and just improving their security standing overall. Now I'd like to come back to other things we can do to control our developers and make sure that they're doing things smartly and securely. And that comes to organization policies. Organization policies are essentially the settings for my cloud. They're like the control panel on my phone. You just go through periodically, and you see what we've launched recently and see if they're useful to you. We will go off and release new settings every couple of months based on what we experience customers asking for and what we ourselves have developed to protect our use of Google Cloud. I'd like to call out a couple of different kinds of organization policies that should probably apply to all enterprises and should definitely be top of mind. First, let's talk about credential exfiltration. It's easy for a developer to go and create unmanaged credentials that can grant access to resources or virtual machines in your cloud. These organization policies allow you to disable that functionality so that developers are pushed and nudged into the directions of using more managed credentials. Disable service account key creation prevents the creation of external private keys for service accounts which can grant access to cloud. Compute require OS login mitigates the risks of leaked SSH keys used for SSHing into VMs. OS login also, by the way, allows you to use IAM itself as a mechanism for controlling who can SSH into virtual machines. The second thing I'd like to talk about is data exfiltration. We have two policies in this area. One called allowed policy member domains, which essentially allows you to constrain who your developers can grant access to in IAM policies. Without this setting, you can grant access to your resources to any individual or service running in your cloud, in somebody else's cloud. You can put it on the public internet if you want. You are free to do what you want. If you apply this organizational policy, it will constrain it and make sure that any identity that's been granted access to your resources is owned and under your organizational management. Compute.vm external IP access disables the ability for your developers to deploy virtual machines that connect directly to the public internet. And this has two functions. One, it can save you money if they aren't strictly needed because public IP addresses are somewhat expensive. But in addition, it prevents your developers from connecting their VMs to the public internet without your knowledge and without approving the mechanisms that they're using to do so. Finally, I'd like to talk about two other controls which allow you to control the types of workloads and the type of software running in your virtual machines, and in particular, trusted image projects and require shielded VM. Trusted image projects allows my image team to have assurance that only operating systems created by them are being run in my cloud. If a developer tries to deploy their own operating system image or tweak the operating system image and deploy that, they'll be disallowed because it violates this policy. Require shielded VM prevents the creation of VMs that do not use a trusted chain of boot through a virtual TPM, through the firmware, through the operating system to make sure that only trusted code is being run in your cloud. If malware or rootkits come into the situation, they're prevented from running. Finally, I'd like to talk about compliance. No talk of security and governance is complete without compliance. As many of you may already know, everything at Google in Google Cloud is encrypted at rest. We do not store any data that's not encrypted at rest. However, for compliance reasons, many customers and many enterprises have reasons that they want to control the encryption key used for encryption at rest. We provide that functionality via Cloud KMS in most of our Google Cloud products, and supports a variety of encoding protocols and encryption protocols, and you can pick and choose. And if you want, then you can delete the keys, and all data is then irrevocably lost. Finally, I'd like to talk about access transparency. Google does not access your cloud resources for any reason besides fulfilling our contractual obligations to you. It's just a matter of fact. We will get in there if you file a support ticket, and a customer engineer will help you debug the problems that you're having, and they'll be able to help see your cloud and help you manage it and debug it. Also, our operations teams will sometimes access resources to prevent outages, which is usually helpful. That said, if you need additional transparency, we can give that to you. With the right support package, you can get logs of every time a Googler accesses your data, and you can see exactly what they did and what support ticket was used to justify the access. Furthermore, many of our products are now supporting what we call dual access, which requires multiple Googlers to collaborate in order to debug any customer issue or any customer problem, thus ensuring additional security for your data. That said, I'd like to change up the topic and switch to saving money.
Awesome. Thanks, Cash. So the last thing that we want to do now, we've talked about how to work to simplify your deployment and management of VMs. Cash just outlined some of the tools and the automation, like the IAM role recommender, for helping you automate your security and governance. And so finally, we want to close with the intelligence that we're surfacing to help you save more money on GCE. And so the way I want to do this is frame how we're thinking about costs on GCE, and then unpack how we can help you save in various areas. And so understanding your costs is the first part of how you save money. And the way that we think about it is our costs we have something that we call resource-based pricing. And so this means everything is modular, and you can imagine there's the base instance, that's your cores in your memory, and underneath that you can select one of the different instance families that I spoke from earlier, and then you can attach resources to it. So accelerators, PD, licenses, other things like that. And if you can imagine, under each of these, there's a modular knob, a dial that you can turn and pull back or push up to increase or decrease the amount that you want to purchase of this. And so this becomes a really powerful lever or mechanism that we'll show you later on how we can use it in a real example to save your enterprise money. And so the way that you can use this and understand your costs today, and these are tools that I use on my own personal projects. The first one is let's identify what's running on your cloud. And there's two APIs. One is the list API. This tells you all the instances that you have up and running on Compute Engine. And the second one is the describe API. So describe tells you, again, the specific, back to that modular resource-based pricing where you have your instance and the accelerators. You can see the licenses that you have attached on. Maybe you have a Windows license attached onto an instance that you didn't know you had, or other things. Maybe you have some RHEL licenses. So each of these, this helps you understand, and you can loop through and see all of what you're paying for and what's running at this moment. The other side of the coin is let's figure out what ran. And you can do this through BigQuery billing exports. So you can set up a data sync and send all of the usage data that you've been consuming over time. And then BigQuery is something that I've grown to really, really enjoy, in the power of being able to just write a SQL statement to figure out everything that you want to understand how much you spent over what period of time. And again, there's templatized versions of this, so you can go out and see. You don't have to start from scratch, and you can just pull these SQL queries that show you, here's how I understand how much I've spent on Windows licensing, or how much I've spent on accelerators, or other things like that, right? And so the one best practice that I see with using BigQuery exports is around this notion of implementing chargebacks. So a lot of these enterprises have different lines of business, LOBs across scattered, and they're sprawling like Cash alluded to. They're sprawling it and consuming resources left and right. And it's hard to figure out how much you want to charge to your e-commerce business or your HR team or your finance team or some dev and tech team, right? And so what you can do is you can implement these things called project labels or tags, and you can label these resources such that when you're calling that BigQuery export, you can throw in and say, give me everything that's been tagged with an e-commerce resource. And what's nice about this is when you tag this, you can also use IAM and revoke their privileges so that they aren't going in and updating the labels there. So it's kind of locked in, and you can figure out, hey, here's what my e-commerce team is spending. Here's what some other team is spending. And so next, now that we've talked about how you can understand your costs, let's get into maximizing your savings. Again, this is predicated on that initial slide where I showed the base VM and the attachable resources onto it. And so we're going to start with a real-world example, and this is Example Inc., but I assure you they're based on a very real customer. And in Example Inc., they spent about $900K on their base VM, so and they had attachable resources, some GPUs, some PD there, and then a handful of Windows licensing. And so what I'm going to do is I'm going to walk through each of these and show the different intelligence that we surface to help you turn down the dial. And this is extremely valuable because a lot of times when you're looking to migrate your enterprise over to cloud, there's this pressure to get it just right? You don't want to spend too much money, and you don't want to have this giant waste. And so I'll show you how we have a lot of tools to help automate that process and let you know, hey, here's where you're spending too much money. And it starts with this notion of custom machine types on our general purpose instances. And custom machine types, the idea is a lot of your instances might not match the perfect shape, right? And so what you can do is you can pull these levers and add CPUs, add GPUs to fit exactly what your workload needs. And to give you an example of the power of custom GPUs, it's when you're looking to right-size your instances, a lot of providers will force you into this power of 2. So think 2, 4, 8, 16, 32, 64. That number that's the integral which you can operate at in terms of granularity. And so what custom machine shapes allow you to do is say, hey, if you have something that's running on-prem and you actually only need 20 cores, instead of us forcing you into a 32-core machine, you can pick a 20-core machine, right? And this is, again, this notion of not forcing you into powers of 2. Powers of 2 are maybe helpful for the provider, but they are extremely wasteful for you. And so what we have here is right-sizing recommendations. Right-sizing recommendations, I just want to spend a moment on this because I think this is kind of a microcosm for how we approach and think about costs on GCP. But right-sizing recommendations, you'll see, we will actively surface for you when we think you are spending too much money on your instance. So if you have an instance that's configured at maybe 32 cores, because that's what you were running on-prem, maybe on another cloud, and you've moved it over, and actually you only need 20, right, or only 22, we will surface up these recommendations for you and say, actually, you can save this much money a month if you downsize based on your usage, based on tracking the trends of your utilization for that workload. What's neat about this is you can deploy it in one click, so you can say, apply recommendation, or you can actually access it programmatically through API. So you can just have something running in the background and just looking for right-sizing recommendations to, again, minimize your footprint on the instance. So now that we've done that, we ran that exercise, and this company saved about 4.9% on their instances through right-sizing. Next, let's get into the GPU resource. And again, GPUs, you don't have to stop at right-sizing at just the cores and RAM. You can do it with GPUs as well. And so instead of paying for maybe 8 V100s, you can purchase just 2, and it's not kind of tied and tightly coupled into the machine type that you need. And so again, this can be very powerful for certain types of resources that you might need and then find out you don't need later. And so with GPUs, they saved about 5% here. And then let's go into PD. This is a pretty low level here, but effectively, there's 3 tools that we have that allow you to automate the process. The first one is we can help you auto-delete. You can set your disk to auto-delete. And the notion here is that over time, you can have a lot of disks that are orphaned, right? And they're just sitting around, and next thing you know, you have this entire weird space, kind of like my, parts of my garage that are just, I don't know what's there, but they're there. And so you can set these to auto-delete and auto-clean themselves. Another mechanism that you have is you can leverage snapshots. Again, I alluded to the power of snapshots earlier, of being able to capture, and this allows you to use snapshots to capture the delta instead of paying for the full disk. And then lastly, you can, if you don't have high performance requirements for SSD, you can just use standard PD instead. And so that's another option that you have available to help you cut down your persistent disk cost. And so here they saved about 1.2%, and these numbers are in aggregate, so it's off the 1.4, 1.5 million. And then the last one, everyone's favorite topic, is licensing. And so there's two mechanisms that you have for dials for adjusting licensing. The first is calling back to that extent the customizable machine types. You can use extended memory. So if you have, here's an example. If you have a database, let's say SQL Server running, and it doesn't need a lot of compute, but needs a lot of memory, you're charged on the core cost, right? So if you're charged on 8 cores per hour, that's what you're being billed at. But if you need a lot of memory, instead of forcing you to pay 16 cores per hour worth of licenses, you can just hit the extend memory button and allow you to keep that same 8-core instance and just add more memory. So you're fixing your licensing costs there. The other thing around licensing is bring your own license. And there's a lot of things that we can dive into here. But at the core, we provide the flexibility for you to bring your own RHEL, SUSE, and Windows licenses. RHEL, you can do this through an image import. We have an option for you there. For SUSE, we have GMIs available for you in the marketplace. You can say, I want SUSE, I think they call it bring your own subscription, BYOS. And then Windows, we also have the option for you to bring your own Windows OS as well as the different applications, so SQL Server. And the way that we think about licensing here is licensing can be an extremely expensive, kind of a pernicious part of your cost. And what you can see here is if you were to buy 1 core hour of a Windows VM, about 33 cents out of 8 cents would be going to your licensing. And so when you can bring your own license, and typically the rule of thumb, and we do recommend you check with your reseller, but one thing that we try to do is we actively work to help you demystify your licensing. So we will work with you to help you understand what you may or may not be able to do with your licensing. And so that's one component. The other component is for BYOL, there's also the on-demand option, which you can purchase, and that might be more valuable. Instead of hanging on to your old enterprise licenses, you can run on demand for those maybe more spiky workloads that are coming in and out, so you're not paying through this EA over a long period of time. And so in licenses, they saved about, we were able to cut 3.9% of their overall cost, 670K there. And so you can see here through the power of resource-based pricing and these modular levers that you have to pull for each of these, you can save a lot of money. I think in aggregate, they saved about 15%. This is after the fact. This is just through a brief afternoon of looking at some things, right? And so we wanted to close on this. Running an enterprise cloud can be very difficult. As quoted above, when you're doing it right, when you're doing digital transformation right, it's like a caterpillar transforming into a butterfly. But when you're doing it wrong, all you have is just a very fast caterpillar. Or I would posit actually just a caterpillar with very tired legs. And so one thing that we are hoping, and what we are spending our time and energy here is, we hope to provide the easiest cloud for you so that we can have a cloud that works for you. And it's this idea that if we can provide you with automation, with intelligence, with ease of use, and couple that together, we can allow you to spend less time thinking about how to run fast, and then more time figuring out how to transform your business. And we hope to help propel that digital transformation through this innovation, through this time, and ultimately through being the easiest cloud for enterprise. We like to, for more information on this, there are breakout sessions happening tomorrow, this afternoon and tomorrow, talking more about the different ways that we're innovating and making cloud easiest on compute engine. As I mentioned earlier, your feedback is greatly appreciated. And then Cash and I will be up here at the end of this talk. If you have any questions, please feel free to come up, and we'd love to talk to you. So we'd like to thank you very much for dropping in. We've really enjoyed it. Thank you all. Hope you have a great day.